Okay, let's take a look at 7 through 20 from the Chapter 2 Practice Statements Reasons handout, which I think is homework number 16. Okay, so for this one, we have AD plus DB equals AB. So this one, isn't that right? AD plus DB equals the whole thing AB. Okay, well, by now I'm hoping that you realize that this thing is really the segment addition postulate. If you're not familiar with it, go back and look through all your notes from Chapter 1, and then email me. Because if you don't know what the segment addition postulate is, we need to meet. Okay, number 8 says angle 1 plus angle 2. If you add those two together, you get this whole angle. Well, that's a lot like 7, which says take two segments next to each other, add them together, you get the big one. It says take two angles together, take two angles, add them together, and get the big one. So that one is the angle addition postulate. Okay. Next one says 2 is congruent to 6. Well, 2 and 6, hopefully you can tell just by looking at it, they form that X shape and they're on opposite sides. So these are vertical angles. So we're using reason number 8 here. Vertical angles are congruent. For 10, we've got an if-then, and the if part is, if D is the midpoint of AB, then this part, AD, is half of the whole thing. Okay, so the ones that deal with midpoints, I'll highlight them, are this one and this one. Now remember, it's got the half AB in there in our problem. One part is half of the whole part. Well, that's what it says right here. Now that's part of the midpoint theorem. So we're going to write midpoint theorem down. Midpoint theorem. Okay, 11 says if DF, where's F? Here it is. If DF bisects CDB, that angle, then 1 and 2 have to be the same. Okay, so we have a bisector, and that tells us that these two angles are the same. So the ones that deal with bisectors are 2 and 4. Now, 2 says if you have a bisector, then you get two angles that are the same. Or if you have two angles the same, you get a bisector. But 4 says if you have a bisector, then one angle's half of the whole thing. That's not what we're looking at. We're looking at one angle's the same as another angle. So this reason here is going to be angle bisector definition. Sorry, I'll write it this way. Definition of angle bisector. Okay, let's look at the next one. ADF, this angle here, plus FDB, this angle here, sum to 180. Okay. Now, some people want to say definition of supplementary because that has a sum of 180 in it. But it's only, you can only do that if you know they're supplementary first. Or if you say supplementary equals sum equals 180, so the angles are supplementary. We don't have the word supplementary appearing anywhere over here. So this one is a different reason. This one should be, well, if you look at it, we're adding two angles next to each other and getting the big angle. But since the big angle, ADB, is 180, you just write the 180 there. So add two angles together to get the big angle. That's the angle addition postulate. Okay, let's keep going. If CD is perpendicular to AB, so if CD is perpendicular to AB here, whoops, CD, AB, then CDB, this angle's 90. Okay, so we need a reason that says if perpendicular, then 90 degrees. Okay, well, let's go back and look at our perpendicular ones. Here's one, here's one, here's one, and here's one. Okay, only one of those says if perpendicular, then you get 90-degree angles. And that's number 7. So we're going to write, whoops, definition of perpendicular lines. Okay, 14 says if 4 and 3 are congruent, then this guy bisects this angle here. Okay, so 4 and 3 are congruent. Well, let's see here. Oh, and then we get an angle bisector, so let's look at the ones that deal with angle bisectors. That's going to be definition and angle bisector theorem. Well, the bisector theorem says you have to start with a bisector and you get one angle's half of the whole angle. We didn't start with a bisector, we ended with the bisector. So it's not that one. Let's look at definition instead. So definition says if you have a bisector, then you get those angles are the same. Or notice the arrow points the other way too. So you could say if the angles are the same, then you have an angle bisector. That's what this says. If the angles are the same, then you get a bisector. Definition of angle bisector. Take a look at 15 and see if you can figure out where the typo is before I start that one. Right. So 15 says 3 and 4 add up to 90. Whoop. Then 3 and 4 are supplements. Supplements is wrong. That should be complements. Right? And if you know 2 angles add up to 90, you don't even need to look at the picture for this. If 2 angles add up to 90, then they have to be complements, right? And that's because of this. If 2 angles, remember, definitions go both ways. So if 2 angles sum to 90, then you can say they're complementary. So this is definition of complementary angles. Okay, 16. If ADF, actually we don't even need the picture for this one either. If ADF and 4 are supplements, then they sum to 180. Well, okay. If 2 angles are supplements, then they sum to 180. That's the definition of supplementary. Alright. Next one says if AB is perpendicular to CE. So let's find AB. Here's AB. And if that's perpendicular to CE, then ADC, oh, doesn't say right angle, it just says ADC is congruent to ADE, which is this one. Notice they're next to each other, these two angles. Okay, so if perpendicular, then I get congruent angles that are next to each other. So again, the perpendicular ones are this one, which doesn't have anything to do with congruent angles next to each other. It just says 90 degrees. We've got this one, which starts with congruent angles, not with perpendicular lines, so it's not that one. We've got 16, which says if 2 lines are perpendicular, then they form congruent adjacent angles. This one looks good to me. And then the last one here, if exterior sides are perpendicular, angles are complementary. This doesn't say anything about complementary here. So we're going to go with number 16. Perpendicular lines give congruent adjacent angles. Okay, the next one says that we've got 4 is complementary to 5 and 6 is also complementary to 5. So we got a couple angles here, 4 and 6, that are complements with just the 5. Okay? And so it says if 4 is complementary to 5 and 6 is complementary to 5, then 4 and 6 are the same. So let's look at the ones that deal with complementary. We've got definition, and we've got exterior sides of 2 adjacent acute angles are perpendicular, then you get complementary. Notice though it starts with perpendicular here and gets complementary. That's not what this says. This starts with some complementary and gets congruent. And then we got one more here. If 2 angles are complements of a third angle, then the 2 angles are congruent. That's exactly what this says. 4 and 6 are complements of 5. So the 2 angles 4 and 6 are congruent. So let's write that one down. 2 angles are complements of a third angle gives you the two angles congruent. Okay. If we look at number 19, it says if 90 degrees, then you get perpendicular. FDG. Right here. If this is 90 degrees, then you know these are perpendicular. Okay, so let's look at the perpendicular statements again. Here's one of them. Now remember that the arrows go both ways because it's a definition. So if 90 degrees, then perpendicular fits perfectly right here. That works. So this, we don't even have to check the other ones. This is definition of perpendicular lines. Then we got number 20. 20 says, if FDG is congruent to GDH. FDG is the one that's right here. And GDH is the one that's right here. And it says if 2 and 3 put together, FDG, is the same as GDH, then we get perpendicular lines. And notice these two angles are next to each other here, this one and this one. Okay, so let's see here. Our perpendicular ones, again, are here. Now that deals with 90 degrees giving us perpendicular. That's not what we say here. We say congruent. We've got if two lines form congruent adjacent angles, then the lines are perpendicular. That sounds good to me. FDG, this angle here, and GDH, this angle here, are formed by just two lines. So it meets all the if stuff, so we can say then that the lines are perpendicular. So let's abbreviate this one. Two lines form congruent adjacent angles. That gives us perpendicular lines. Okay, so that's the end of this page. Find the one for number 21.